Not when done properly and with the appropriate marking technique, and I'll talk a little bit more about that too. So one thing that is very important, as Charlie alluded to, is the proper technique and doing this correctly. These bands have a seam in them, and you have to, particularly with waterfowl, you have to crimp this band tight enough so that the seam wouldn't allow fishing line to get caught in it, or the bird could end up drowning because he's tangled up in fishing line, dying of starvation because he can't move out of a certain area, or having damage done to his leg from fishing line cutting into the leg. So it's not like getting your ear pierced where somebody goes up and goes, done. This is a very important technique to be done properly, and you need to be trained to do it. So, but that relies on, this technique relies on recapture data, returns data. When you're doing sea ducks, that's kind of difficult because they're out at sea. How do you track them? Getting back to the wind farm issue, there was a very, the questions about what are these ducks? This is an eider and this is a scoter. What do these ducks do? Where do they go? Where do they hang out? What pathways do they follow, if any? How do you track that? How do you know you're looking at the same duck? Well, we use transmitters. This is a transmitter that was used in a study to track the migratory patterns of eider. And I don't know, they do it in Scoter too? The Scoter project? Yeah, both the eider and the Scoter project. We use mist nets. It's another common technique to capture birds and other species like bats. Charlie might talk about that a little bit. But this is a mist net that was used. It's a technique that very few agencies in the country use. Rhode Island is one of the very few who use this. And I know it's kind of hard to see, but these mist nets are assembled out on the water in January, in December, in 20-degree weather, in a bouncing boat. You carry all this equipment out there and you assemble it along locations where you know, through use of your observation tools, the target species, in this case the eider, are moving towards. It's a very fine net. That's why we call it a mist net. It's barely visible to the birds. The eider travel in flocks. This is 1/3, and it's not even the whole net. Most of the net is on the ground there. This would be 1/3 of the entire spread of the net, which is floating out on the water. It's anchored on either end, and decoys have been laid out in front of it. The eider come, they see the other eider sitting there, they fly into the nets, they get tangled up. We rush in, take the birds out of the net, put them in crates, and go back and wait for more eider to come. We get those eider, we band them, we weigh them. Actually, I was not part of the scientific collection team. The study was being run by a grad student, Josh Buth, a former student of Pete Stetson of Coventry. A question in the back?
Yeah, how often do people come around to any of that? I mean,
As soon as it happens. As soon as it happens. In the whole process, so the question is, how long are the birds, once captured, are they in captivity? They are released as soon as we can get the bans on them and release them. In the case of the ITER study, it was probably 2 hours at the most. In the case of the duck study that I'm doing, it's 45 minutes to an hour. For one thing, all waterfowl are a highly regulated species, and the federal government has jurisdiction, primary jurisdiction, and the states have secondary jurisdiction. The state needs a permit to conduct this study, to capture these waterfowl, and they put limits on what we can and cannot do. So we're highly regulated, and it's all in the best interests of the birds. With the eider and the scoter, once they were captured, they were weighed, and the hens, because this is not just about the movement of the birds locally and whether the offshore wind farm might interfere with their feeding grounds or whatnot, but we also wanted to know, where do they breed? Where's their breeding grounds? So it's a two-part study. So we wanted to capture the hens because the hens are indicative of where the breeding is going on. This doesn't seem to be that heavy, but as a percentage of these birds, it's a lot. So we would weed out and select only the largest, most fit hens to use these transmitters with. And by most fit, there was tissue cultures done about their body fat. How much? What was the percentage of body fat? And the selected species would then have these transmitters surgically implanted in them. And there are still some out there. And these are programmed. It's a program transmitter. And this one was a two-step program, two-cycle program. For 4 hours a day, this transmitter would transmit every minute where it was, its location, every minute for 4 hours, and then shut itself off for 20 hours. And then it would cycle again, 4 hours on, 20 hours off, every minute. That data was picked up, and I don't know if that was satellite?
Yeah, it's satellite.
Satellite, collected by satellite, and then tracked on a computer, and you could see it on a cell phone.
It has a battery in there, so it has a limited lifespan.
800 hours
Right, and you're limited,
on this one.
right. The smaller you get, the battery life, until the technology is getting better all the time, but it's basically the limiting factor is, you can only go to a certain size without affecting the bird's behaviors or its well-being.
Survivability.
So there's a trade-off, and as technology gets better, batteries get smaller and they have longer life, so you can do more. They have transmitters now that you can put on dragonflies. They have a very short lifespan, but it may be enough, but it's getting better all the time. But yeah.
And the second cycle, one second, go ahead.
You said that the mist nets are used by very few agencies. Why is that?
I say that, I want to clarify the floating mist nets. And the reason that they are not used by a lot of agencies is a lot of agencies have no need for them because they don't necessarily have a CDUC study going on. And the other reason is the difficulty with putting trained people together to do this. We'd have two of these nets out at different locations and probably 6 boats, 4 people in a boat, and to coordinate all that, just to get people to do it in January is hard enough. So that there's a lot of obstacles to that type of thing.
So, what kind of environment
We use this along the southern shore of Rhode Island and the lower part of Narragansett Bay. For sea ducks, yeah. We would use it in the environment where the target species are present. If they're there and there's water, we could use it.
They're only here in the wintertime, so these ducks breed, have their young, spend the summers in the Arctic and throughout Canada and other places. So they winter here along the New England coast and stuff. So that's why the effort, Paul's saying we're out there in December and January, that's when the birds are here. By April, most of them are gone, maybe May at the latest. They're out here.
And one second. And that brings me to the second cycle of this study is beginning in April, this transmitter is on all the time and transmits its data. It's not on all the time, I forget exactly, but it's on more frequently and it transmits its location every minute until the battery runs out. 800 hours of battery life. So that carries, there's enough battery life in here to carry this transmitter from when it starts up in, say, December through March, which is the first duty cycle, and then from that March to the following March. So it's like 15 months worth of transmittable data. Question? It generally just gets left inside the bird. Because it's transmitting its location at all times, we know where the last known spot was, where the bird was. So we can go to that spot and try and recover the band or see if we can find the bird. If the location of the bird is being transmitted as being in the same spot for an overly long period of time, we know the bird is probably deceased, and we can go get it. This transmitter, it costs $2,500, so it's a valuable asset. We had one of our transmitters was saying that it was in Louisiana, and on land, and it kept going back and forth in the same neighborhood in Louisiana. And we were like, this doesn't make sense. So they started going through the records of permits for hunting waterfowl, and come to find out there was a kid from Louisiana who had a Rhode Island permit to hunt waterfowl. So we called him up. They said, hey, is there, by any chance, do you have a transmitter from an eider that you may have shot in Rhode Island back on so-and-so? Why, yes. Yes, I do. I said, well, do you think we could get it back? It's $2,500, and it's very expensive. We'd like it back. We'll send you one. We'll send you another one that's no longer useful as an exchange. And in the background, you hear him talking to his father. He said, Dad, Rhode Island wants this back. It costs $2,500. See how much they'll pay you for it. And we said, nothing. Said, then nope. They didn't send it back. But we know where he is and we know where he goes.
Yeah. But I think your question, once the battery expires on that basically, it's surgically implanted in the bird, and so basically the bird's going to have it for life. There's no to retrieve it or drop off. Some collars you'll see for terrestrial species like coyotes or whatever. There's mechanisms so that after a certain amount of time the collar will drop off, and then you're able to retrieve it, you can find it. But in this particular, these basically were considered expendable. That the data you're going to get is going to be worth it. So there was no, I guess, hope or promise that you